This is a personal cloud storage that I built with an OrangePi, including this 3D printed case. You can keep it at your home and can access from anywhere in the world to save and sync your files. This is similar to, for example, OneDrive or Dropbox, but you don't need to pay any subscription scam and your data never leaves your home. I have 2 terabytes of NVMe storage in this one, but you can also use external USB storage via the USB 3.0 port. So in this video, I'll go through all the steps of building this and what hardware components I have used and what are the things we have to install in the software side. We'll also look into the designing of this 3D printed case and assembling it. And at the end, we'll also see how we can control the fan speed according to the CPU temperature. So I am using this OrangePi 4 Pro. You can use other OrangePis or Raspberry Pis. At the time of buying, I found this one the most cheapest, especially after this price fixing by this memory cartel mafia. Everything is so expensive, so it's difficult to find a cheap SBC these days. So I'm using this OrangePi 4 Pro. It has a total 8 core CPUs, go up to 2 GHz, 6 GB of RAM. There are other versions with 4 GB, I think up to 12 GB of RAM. This has Wi-Fi 6, Bluetooth 5.4, also has some NPUs and also a GPU. And here you have this USB-C for power input, HDMI audio, and there is one USB 3.0 port and 3 USB 2.0 port. And the good thing is that it has this M.2 slot where we can use M.2 NVMe drives for storage, and we don't need to buy an extra NVMe adapter for like most of the versions of Raspberry Pi or other SBCs. I will use this Samsung 970 EVO. This is PCI 3, a little bit older, but this board also, this M.2 slot is also PCI 3, so there is, it will be okay. And especially in case of cloud storage, the speed will be limited by the network speed. So I think this 970 is more than good enough. I have also ordered the 64 GB EMMC card. So I'll keep the OS in this EMMC and I will use the M.2 only for storage. I also bought this few heatsinks. These are 14 by 14 and the bigger ones for bigger ICs, and this 9 by 9. This is I think power management CPU. I have also bought this heatsink for the M.2 drive, and we have to remember about the extra space they will need when designing the case. And then I am using this PWM fan for active cooling, and this blue wire is for the PWM signal to control the speed. So to install or basically copy the OS into this OrangePi, I will use this MicroSD card, and then I will transfer this to the EMMC card via the OrangePi. There is also USB adapters available for the EMMC cards where you can directly copy the OS image to the EMMC, then you don't need the MicroSD. So if you have that, you can use that directly. Now this is a very new board, and at the time of recording it does not have any Armbian or DietPi. So you have to go to the OrangePi website and then we'll download this Debian version. And it has both Bullseye and Bookworm. Bookworm is the newer, but I will download the Bullseye because in the OrangePi manual I found that Bullseye has better compatibility. So I'm downloading the Bullseye and I'm downloading this headless server version. We don't need any GUI for this cloud storage setup. To transfer it to the MicroSD, I am using this default USB image writer from Linux Mint. If you don't have it, then you can also use tools like Balena HR or Unet Bootin. There are many tools available. Okay, so after it has done, plug the MicroSD to OrangePi, and for the first time we need a keyboard and an HDMI monitor. So now I have connected an HDMI monitor and a keyboard to the OrangePi, and it is now booted, and we have this command prompt with the OrangePi 4 Pro text with some info. First thing we have to set up is the Wi-Fi and SSH. If you use the Ethernet, then you don't need to set up the Wi-Fi with password. To set up the Wi-Fi in this text mode, you can use this command nvme device Wi-Fi list, and this will show the list of Wi-Fi's with names. Then to connect to a specific Wi-Fi, we can use sudo nmcli device Wi-Fi connect, and then the Wi-Fi name, SSID name, and here is the Wi-Fi password, and the default sudo password for OrangePi is OrangePi itself. So the Wi-Fi is now connected. The first thing we can do is to sudo apt update and upgrade. Okay, then we have to enable the SSH. For that, we have to go to this OrangePi config, system, and SSH, and it will install a few stuff. Then save, go back, and exit. And the final thing before removing the keyboard and monitor, we have to find out the IP address of this OrangePi, and for that we can use the command IP add show, and the IP address starts with like 192 point something something, or you can also use this command hostname -i. Okay, now we are ready to remove the keyboard and monitor and transfer the OS to the EMMC card. This is the screen from my computer, and we can now connect OrangePi via SSH and IP address. The password is again the OrangePi. So here again we see the prompt from the OrangePi. Now we use the command lsblk to find out which storage devices are attached. Now here you can see this MMC BLK0 and MMC BLK1, and the drive it currently booted from is marked with this slash. So this is the SD card MMC BLK1. So we have to transfer the files from MMC BLK1 to MMC BLK0. So to transfer, we use the dd command, sudo dd if the input one, it is the MMC BLK1, the SD card, and OF, this is the output one, this is the EMMC card MMC BLK0, and the status equals to progress to see the progress. It will take some time depending on the size of the cards. For me, it took around 20 to 25 minutes, so you have to wait. Okay, now the OS is transferred to the EMMC card, and then we turn off the OrangePi, remove the microSD card, and turn on again, and it is now booted from the EMMC card. Now if we enter lsblk, as you can see, it shows there is only one MMC BLK 0 now, and it is the boot drive. Now at this point we attach the M.2 NVMe drive. Actually you could plug all the things, the EMMC and the M.2 card, since the beginning of the installation, but here I am doing step by step just to show that they are detected by the OS and which devices are connected from the software side. Now again we are logged into the OrangePi, and now if we enter the command lsblk again, it shows this NVMe 0N1 of 1.8 terabyte, and this disk also has this partition, as I was using this disk before. So the disk is now connected, and you can mount the disk into a directory and can see if it has already some files in case you want to take some backup. So here you can see that. You can also open the drive with your graphical file browser by using the SFTP protocol. Now in my case I do not have anything in it, so I will just format it straight away with the ext4 file system, the Linux file system. So first unmount it, remove the test mount folder, and then I format it using sudo mkfs ext4 and then the device name nvme drive. Now here I kept that same single partition that was here before. If you want to change the partition structure, you can use the fdisk command to do that and follow the instructions after the command. Okay, now it is formatted with ext4. Let me give the drive a name. Okay, now to mount automatically every time after reboot, we need to add the mount entry in the etc fstab file, and for that we need the id of this partition. To find the id, we can use this blk id command, and again we make a folder to mount this partition just like before. So yes, and then finally we add the entry in the etc fstab, and here we need that id for that partition. Copy paste it from the previous step, then the mount folder name ext4, and here are some trivial options. You can look it up what they mean, and we save and exit. And after reboot, the partition will be automatically mounted, and then we can see the content of the partition from both the command prompt and also from the file browser using the sftp. So at this point, the device is fully set up for access from my home network. But to access it anywhere from the world, we need one more thing, Tailscale. What does it do is to create some sort of mesh VPN network so that all the devices with the same account can see each other from anywhere in the world. And that's without knowing any IP address. You just have to give a name to the device, and we can connect it to the device just by their name, no matter where we are and which network we are connected to. Generally, installing Tailscale is very easy. You just need to run this command given in their website, and that's all, and it will start running after installation and will show the login link. But I found that this command is not sufficient for OrangePi. It does not run after installation and do not show this login link. So the kernel for this OrangePi is built without including something called tune. What we have to do is to run the Tailscale with user space, and for that let's create a service first so that it can run automatically after every reboot, and give any name. Here I am using Tailscale d user space dot service, and in that we need to add a few trivial things, and here you can see that this parameter tun equals to user space networking. Okay, then save the file and then activate the service. Remove the default Tailscale service just in case it was enabled from before, and then start the service again. Now if we see the status, it says logged out, and this is the web link for the login for this device. So copy paste it in the browser and log in to your Tailscale account, and it will add this device. Now we can check the status of the Tailscale, and it will show all my devices connected to my Tailscale account. I have now 3 devices, and the point is that I can access all these devices just by their name without any IP address. And you can give any name you will like that you can remember. For example, let me change the name of the OrangePi. So let's say PiCloud. Now we can connect it just by this name, SSH OrangePi@PiCloud. And this you can do from any network, not just your home network. And we can also connect it from our file browser by calling it via SFTP with its name, no IP address. And this syntax may be a little different for Windows, and just look it up in Google. And then we can just bookmark this place and rename it. And if we close everything, then every time you open it, you can just click on this bookmark in your file browser, and it will show up our storage folder in the OrangePi. Now one small thing, we see this cross sign on this folder, which generally means that we don't have the ownership of the folder. So we need to take the ownership. So we can use this command to take the ownership, and now we have ownership for the user OrangePi. And see that the cross sign is now gone, and we can put files into the folder. One small thing I forgot to do before is to create a user with my name instead of OrangePi and use a custom password. So let's do that now. If you want to keep the same OrangePi user and want to change only the password, then you can just use the usual PASSWD command. But to create a new user, we can use this add user command then just add some trivial stuff. Okay, then we need to give some configurations to the user, and then finally we have to give the ownership of the nvme partition to this user. At this point we can also delete the default OrangePi user if you want. So now, as before, we can connect the folder from the browser, and we can bookmark it and can access our cloud folder just by one click from anywhere in the world. So the final thing we have to do from the software side is to install Syncthing. This is only necessary if you want to set up auto sync with some folders with OrangePi. But if you don't need any kind of auto sync and only save or copy things manually to the cloud storage, then you don't need any Syncthing. So to install Syncthing, and go to their website, and we need to just run these commands given in their websites one by one. And after that we need to enable the service so that it can run automatically after every reboot. Okay, so the Syncthing is now installed. To activate the service, we have to use this default command, and then you can check the status of the Syncthing, and it is running. Now to access the web UI of the Syncthing, for choosing, for example, the folders to sync, etc., what we generally do is to open the localhost 8384 port via the browser. But now as we are connected to OrangePi via SSH from our computer, if we open that, it will open the Syncthing web UI of this computer, not the OrangePi that is connected via SSH. So this Syncthing web UI is for this laptop, not for the OrangePi. So to open the Syncthing page of the OrangePi, what you can do is to connect the 8384 port of OrangePi to some another port of this computer, and for that we need a terminal of this computer, and then can use this command in the terminal. So what it will do, it will connect the 8384 port of OrangePi with a new port 8385 or this computer. Okay, now it will not show anything, but if we close this terminal, then this port forwarding will stop. And if you want to run it in the background permanently, then you can just add a small f here, small fn here. And now if we open the localhost with this new 8385 port, you can see this Syncthing web UI, which is from the OrangePi, and this other one with the 8384 port is from my laptop. So now we can add folders here and set up the sync as we need. And you should add some username password for this GUI, just like here. And you also can disable the global discovery in the settings, because we have Tailscale now, and all the traffic can go via our Tailscale network, and we don't need any public relays. And if you want to sync files with your mobile devices, you can use this Syncthing fork for Android, this one, and for iOS you can use this sync train. I have used both of them quickly. It seems they work, but I have not tested them rigorously, so let me know if they works properly or not in the comments. Okay, so that's all from the main software side, and all the commands I have mentioned here, I will list them in the video description. And the things are left now are the assembling the Pi in the 3D printed case, which I will show in the part 2 of this video. I will also show some overview of the designing the case, and then in part 3 of the video I will show how we can control this fan speed based on the temperature of the processor. So please subscribe to get informed about the next part, and if this video was helpful, then give me a like, and thanks for watching, and I will see you in the next parts.